this question mark over here and all these grids. Okay? And what we're going to be doing is we're going to create a mesh, and I'm going to leave it as 1,500 elements. Okay? And I'm going to hit discretize and mesh. Okay? And what it's going to do, let me enlarge it a little bit, is going to draw all these triangles, you know, through the mesh. If you want to have more density, let's say at the location where the dam is, you can go to the mesh. Again, you can say increase density, and you can, for example, create a window where you're going to have more of those triangles. Okay. If you don't like it, you say, well, maybe my density is not big enough. I'm going to put, let's say, 5,000. Okay? You can redo it at any time. And the colors here are not the best choice of colors, but you see these are little triangles, and each one of those triangles is kind of going to analyze the Laplace equation. You know, the water coming in one direction, the water coming out in the other direction. Okay. The next thing we have to do is we need to give some boundary condition. Okay? And I see a lot of people have stopped writing. Okay, so we need to discretize, mesh, and now we need to give boundary conditions. And that's going to tell the computer where the water is entering and where the water is exiting. So it's going to enter over here, flow through here, and exit here in the back. Okay? So for boundary conditions, this is the symbol for boundary conditions here, or if you prefer, Control B. Okay? And what I'm going to do first is I'm going to get rid of many of these boundary conditions that the computer has actually drawn by default. So I'm going to get rid of this one, and 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 this one. Enter. Okay. All right. So I have a higher reservoir on this side, and this is where the water is going to enter. So if you all agree, you see the scale here says 10, and there it says 15. I'm going to put something like maybe 18, just for the purpose of getting the water in. So total head here, I'm going to put here 18. And I'm going to click on this boundary and click apply. And you should see this. You know, basically it's telling you the water level of the reservoir above the ground at that point. Okay? And let's assume here in the back, I'm going to put maybe a lower number. How about 13 meters? Okay. And that would be in the back of my net. And click apply. So now I have a big head of water along the reservoir. On the reservoir side, I have a little bit of water on the downstream side, and I have nothing here. Nothing means that that boundary is impermeable. That water cannot get out. Same thing as the base. This could be, for example, the depth to your impermeable bedrock. Okay, and here on the sides, we don't allow the water to get out. So once you're done with that, you have the calculator here, and you ask the computer to calculate. It asks you if you want to save it, and normally I give a file name that includes the date. now. It's done. Okay. So it's solved on the order of, I think we said 5,000. So it's solved in the order of 20,000 equations with 20,000 unknowns. Okay. So what we're seeing here being plotted is the pressure head, but if you wanted to get, for example, the pore water pressures, this would be the drawing of the pore water pressures. Okay, so the computer has not only done the seepage analysis, but it's also done Bernoulli's equation to actually calculate the water pressures at any point. Yes? You click the calculator symbol. There's two software. There's Slide, okay, and on Slide you have the calculator here, okay. Once you click on the calculator, it calls the plotting program, which is this one here. It's called Interpret. But the moment you hit calculator, it will automatically pull in the plotting software. So that's why you saw another icon over here with the plotting itself. Okay? If I plot here on the vectors, it's going to actually show me how the water is flowing. Okay? So the water is entering through the reservoir. Big vectors means that there's a lot of water entering over here, and as you go further out, there's vectors on the smaller side. It goes under the sheet piles, it goes a little bit under the dam, and eventually seeps out at the base. Okay. And if you want to draw flow lines, it has some symbols here for add a flow line. I normally add them manually. I like to do them one at a time. And so we can come over here, start with this point, and that gives me, my flow lines one by one. So it's much easier, but less artistic than drawing flow lines by hand. Okay. I know you like artistic. You prefer to do it by hand, right? I see. You must be engineers. You're all going like this. All right. So this is how people typically do it in practice. There's some tremendous advantage. Okay, let's assume for a moment that you want to know the amount of flow that is traveling through. Okay, well, we're going to put, you see this arrow here with 2 points. It says add a discharge section. So we're going to add one. And normally when I put discharge sections, I like to have more than one. So I'm going to put one like this. Oops, I made a mistake. So let me try again. This touchpad is a little tricky, so enter. There we are. I'm going to put maybe another one over here. It's good to put several so that you can double check the numbers. I'll put 3 of them if that's okay with you. So what the computer will do is it'll calculate along this line how much water is crossing that boundary, how much water is crossing that boundary, and how much water is crossing that boundary. The 3 numbers should be the same, but because of rounding errors and numerical methods, you don't get exact numbers. Let's see how close they come. So I'm going to hit again the calculator. Okay. It's going to check my problem a little bit. Okay. And the next here I'm going to go to the interpret. Okay. And it's telling me that there's about 0.012 cubic meters per day flowing through here per meter perpendicular to the board. Here it's telling me it's about close to the same number, 0.0115 or almost 0.12. Okay, with the rounding you get roughly the same numbers. You never get the same numbers. Okay, usually the first digit is always there, the second digit with rounding is there, but it's much more accurate than what you will ever get by drawing the flow nets by hand. But one of the things that you can do with this type of software, which is very useful, is you can analyze the what if you're wrong type of situation. Let us assume for a moment that your geologist tells you, you know what, I think there is a gravel layer here, but our borings are not deep enough and we never found that gravel layer. Okay, but I think it's a gravel layer that is very, very permeable. You should be careful because a lot of that water is going to travel through that gravel layer. Okay, so one of the things that we can do is we can change fairly quickly the geometry. Okay, so I go back to my boundary, my geometry. Okay, and I can, for example, create a layer. Okay, how are we doing in terms of okay. And I'm going to create a layer over here. And let's assume that that layer is relatively thin. And I'm going to go back to groundwater and properties, define hydraulic properties. This, I need to first choose the material, sorry about that. So I'm going to go under properties, assign properties, and I'm going to call material 2 the material in this zone. Okay? And then I'm going to give it a permeability that instead of 10 minus 7 is, let's assume that this layer is 1,000 times more permeable. Okay, or 10,000 times more permeable. So, oops, that's material 1, sorry. So that would be material 2. And I think material 1, I changed it by mistake. And 10 minus 7 for 1, and 10 minus 3 for the other one. You have to excuse me, this keyboard is kind of bad. Okay. All right. So what we can do is redo the calculations. Okay. Oh, I need to, because I put in a layer, I need to discretize again. And now I can do the calculation again. So you'll see that in that layer, it's put a whole bunch of little triangles. Calculation is done. And let's see what happens with the vectors of water. And what you're seeing is now that most of the water is now traveling through this layer, and that the effect of that layer is roughly to increase by about 800% the amount of flow that goes from the upstream to the downstream. Okay? So one of the things that these type of softwares allow you to do is they allow you to do a lot of calculation very fast. Okay, for your homework you need to do one more thing, is you need to analyze a dam. And I think we can use this one over here.